Okay guys, 14.3 is just a quick comparable version of double integrals using polar coordinates. So instead of x and y, we can use r and theta. So as a reminder, x equals r cosine theta, y equals r sine theta, x squared plus y squared equals r squared, and tangent of theta equals y over x. That's just a reminder. Describe the following shapes in terms of r and theta. So r, our radius in this shape, goes from 0 to 2. Theta goes from 0 to pi over 2. In the second shape, our radius in the donut is from 1 to 3. And our theta goes all the way around, which is 0 to 2 pi. In the last shape, our radius changes depending on y. So that means this ends up being, take the average of 6 and 0, it's 3. So we know there's a baseline 3, and it's adjusting up or down 3 with y. So it's 3 sine theta, and it also goes around all of the way. So these are just another way to define the function in terms of r and theta. So change of variables to polar form. If R is a plane region consisting of all points x, y, satisfying these conditions, again, upper and lower bounds for each, then the double integral of f of x, y, dA can be converted to polar coordinates, where we evaluate the functions in terms of theta first. Actually, I think we integrate usually first with respect to r, then we integrate with respect to theta. But it's all that multiplied by r. There's a change of variable here. We aren't going to talk about that. It's something we did at the end of Cal 2, very briefly. But don't worry about that so much now. Just make sure you multiply by r in the function. Okay, so let r be the annular region lying between the two circles, x squared plus y squared equals 1, and x squared plus y squared equals 5. Evaluate the double integral x squared plus y dA. Okay, first off, let's convert. Since x squared plus y squared equals r squared equals 5 here, so r equals the square root of 5. Here, it's r squared equals 1, so r equals 1. It's above 1 and below square root of 5. It's two circles, so we know theta is between 0 and 2 pi. Okay, so what does that mean? We've got the integral from 1 to square root of 5 and the integral from 0 to 2 pi. Now, we have x squared plus y, so we know x is r cosine theta. So this becomes r cosine theta squared plus r sine theta. So just converting the x and y to polar coordinates, and this whole thing needs to be times r first, and we've got dr d theta. So let's clean this up a little bit. R cosine theta squared is r squared cosine theta, but there's another r, so this is r cubed cosine squared theta. This will be r squared sine theta dr d theta. First, we need to integrate with respect to r, so that means this is the integral from 0 to 2 pi. This will be 1/4 r to the 4th times cosine squared theta, plus 1/3 r cubed sine theta, evaluated from 1 to the square root of 5. And with still an integral with respect to theta to go, if we plug in square root of 5, this becomes 5/25. So this will become 25/4 cosine squared theta. This becomes 5√5 over 3 plus 5√5 over 3 sine theta, minus when we plug in 1, minus 1/4 cosine squared theta, minus 1/3 sine theta. 25/4 minus 1/4 is 24/4, or 6. So we get 6 cosine squared theta plus, I'm going to write this all as a constant, 5√5 minus 1 over 3 sine theta d theta. Now we can finally integrate with respect to theta. For cosine squared theta, I need to down convert the power. This is cosine squared theta is 1 plus cosine 2 theta over 2. So this becomes 3 times 1 plus cosine 2 theta plus 5 square root of 5 minus 1 over 3 sine theta, so that I can integrate. When I integrate that, this becomes 3 theta plus the integral of 3 cosine 2 theta is 3 halves sine 2 theta. This becomes minus 5 root 5 minus 1 over 3 cosine theta, all evaluated from 0 to 2 pi. Now, because cosine 2 theta is the same at 0 and 2 pi, this isn't going to matter. They're going to cancel each other out when I plug in both. So I really just need to plug these into sine theta. So 3 times 2 pi, 6 pi. Similarly, sine of 2 theta is the same at both of these. So these are also going to cancel. Anyway, it's 0 plus 0. This would become minus 5 root 5 minus 1 over 3. And then plus 5 root 5 minus 1 over 3. So this whole thing is 6 pi. And that is all for 14.3.